So if you look at number 1, we're saying, hey, could you go ahead and write down the equation? We give you some info. So could you use the information to write the equation in vertex form? So you know your vertex form, right? Your vertex form, it's y is equal to a times x minus h squared plus k. Okay, that's the vertex form. And then the given information is like, oh, hey, yeah, we have the axis of symmetry, x equals to 3. I'm going to give you 2 points. Okay, we'll give you 2 points. So now we say, well, what can you do? Can you see a little special information that's kind of embedded in the given information? The vertex. How do you know it's a vertex? Yeah. So if you are very careful, you're like, wait, hold on. X equals to 3. And that number right here is 3, 1. That is having the same x value as your axis of symmetry. So this is actually the vertex. Now, if you say, my eyes are not that sharp, what can I do? Well, if your eyes are not that sharp, then do something so that your eyes can spot it out easier by graphing it out. So you say, oh yeah, axis of symmetry is x equals to 3, and then we have a point which is, oh, it's x equals to the point is 3, 1. Then immediately you will know that, hey, that must be the vertex. So do something to help yourself. Okay, and then you can say, oh yeah, there's another point right here, 2, 3. Okay, so this is 3, this is 1. Now, what do we do then? We say, well, let's go ahead and write an equation. Okay, we have the vertex form, right? And we know the vertex. That means now we can actually plug in the value for the x and y value of the vertex into the equation. And then we say the only thing that's lacking, it's our a value. Okay, we need to know our a value, and then we say, oh, well, how do you know your a value? And we say, well, you know your x and y, right? Because you have another point. Use it. Okay, use the 2, 3, the other point, and say, yeah. So you can go ahead and put in the 2, 3 right here from this point. And now, can you look at what you see here? Can you look at what you have? Everything but a. That means you could find out the a value. Now, one thing that I would remind you is that make sure you are looking at your own handwriting. Okay, what I'm worried about is that some students will forget that there's a little square right here. And when they are focusing on substituting, they forgot to write the square, and that could cause some trouble. Okay, so in this case, we're like, oh yeah, so 3 is equal to a, and this would give you -1. -1 square is just 1. And 1 times a is a, so a plus 1 is equal to 3. That means a is equal to 2. Okay. All right. So you could find out that a is equal to 2. So your final equation, it's going to be y is equal to 2 times x minus 3 squared plus 1. Lovely. Lovely, lovely, lovely. Okay. Now, if you are even smarter, if you are really good with graphing, I would say you can actually spot out the a value being 2 if you actually see the graph. Because you're like, wait, hold on, I know how to graph a quadratic. It's usually 1, 3, 5, right? But if you look at the y values here, you will say, wait, hold on. You go to the left by 1 unit, but then you go up by 2 units. Well, that would only happen when a is equal to 2. Okay, if you are that sensitive, you can go straight and say, oh yeah, the A value is 2 because it went up by 2 units. When we go to the left by 1 unit. Okay, but if you want to have something that's more reliable, this would be a very reliable approach to find out the A value and get the equation.